ready for the 50-hour inspection of engines and propellers. But before propeller inspection, the familiar cry, "Switch off," is given Sergeant Moore in the cockpit. He makes certain the ignition switch is in the off position, then he relays the information back to Becker. Then Becker and Sullivan inspect each propeller blade by pulling and pushing to see if the propeller retaining nut is tight. Twisting the blade checks its security of mount. Next, Becker runs his hand over each blade and feels as well as looks for cracks, nicks, bends, scratches, and similar defects. He's found a nick and is going to repair it immediately with a fine-cut file of suitable shape, or he could use an oil stone. He works down the raised edges and rounds out the defect to the shortest possible radius. These are hollow steel blades, and therefore an absolute minimum of steel is removed. To produce a smooth finish after the filing, Becker uses fine sandpaper followed by crocus cloth. Becker also inspects the cuffs and cuff supports, as well as the cuff screws for looseness. Markings stamped into the hub are possibilities for cracks and receive close scrutiny. When in doubt about an apparent crack, he uses a magnifying glass. If there's even a suspicion of a crack, the blade will be magnifluxed. Not overlooking a thing, Becker checks for deterioration of the blade markings and the condition of the blade camouflage. After inspecting the blade, he goes to the tool kit to get a clean cloth and oil. These are used after inspection to thoroughly coat the blade. The oil protects the prop from rust and is apt to reveal additional cracks. Each of the 4 blades is inspected and coated with the same thoroughness. After completing the blade inspection, Becker turns his attention to the electrical conduits leading to the brush block assembly and the governor. He inspects for breaks, frays and wear, and the plugs for looseness. The governor is also tested for security of mounting and leakage. The conduits and cables are okay. Now for the slip rings and brush block. After pulling out the safety pins, Becker releases the 2 latches and removes the brush block assembly with extreme care. When the assembly is taken from the housing, he holds a cloth against the propeller slip rings and wipes them clean as Jensen pushes the propeller through. During this operation, they're inspected for broken insulation, corrosion, and pitting. The slip rings having been cleaned and inspected, Becker goes back to the brush assembly and cleans all the carbon dust and dirt from the brush holder and the brushes. It's particularly important that all the brushes slide freely in the holder and maintain proper contact. If brushes are worn to the tip of this arrow, Becker knows they're not maintaining proper contact and have to be replaced, just as this broken brush will be replaced. To make a replacement, Becker disconnects the brush assembly by taking out the screws at either end. The broken brush is then pulled out and a good one inserted in its place. When the brush assembly is replaced in the housing, the unit is reinstalled and Becker goes to work on the governor and removes the switch compartment cover. He sees that the wire leads are securely attached and that the movable arm operates up and down easily. Then he thoroughly cleans the contact assemblies with unleaded gasoline. This is done to remove any oil that may have accumulated in the switch compartment. Becker uses a cloth to wipe off the dirt that refuses to be brushed out. Then he inspects the points for pitting. A single drop of light lubricating oil is placed on the upper end of the shaft, which supports the center contact assembly. Becker next cleans a feeler gauge of all oil so he can check the governor contact point clearances to make certain the gap in the center contact assembly is within limits. This clearance is in accordance with tech orders, so the cover is replaced. Now Becker turns his attention to the brake assembly, motor and power unit. His first job is to remove and thoroughly inspect the spinner for cracks and dents. His next action is to remove and inspect the electric motor cover. Then he checks the leads and electrical connections for security. He now takes out the nut and bolt which hold the brake cage so the cage can be removed. He does this to check the brake facings for glazed surfaces and uneven wear. The glaze is removed by rubbing the face over fine sandpaper. After he's sure the glaze has been removed from the brake plate, Becker checks the inner brake clearance with a clean feeler gauge. The correct gauge is inserted between the inner brake plate and the inner ring of the inner solenoid housing. The clearance must coincide with the latest technical orders. If this clearance had been out of limits, Becker would have added or removed shim laminations on the armature shaft to make the correct adjustment. With the inner brake clearance within tolerance, Becker replaces the brake cage, tapping it lightly with a soft metal drift and a mallet so it will seat. Then the nut and bolt are replaced and safety. Now Becker checks the outer brake clearance with a feeler gauge of proper thickness. He inserts it between the outer brake plate and the inner ring of the outer solenoid housing. With everything in order, the electric motor cover is replaced and secured with several small screws which are safety. Becker's next important inspection is checking the oil level in the speed reducer. To make this inspection, he first cuts the safety wire and then removes the plug in the unit with the proper size wrench. Having removed the plug, he has Jensen rotate the propeller until the plug opening is approximately 12 degrees below horizontal. As there is a sufficient supply of oil in the speed reducer, Becker replaces the plug and safeties it. Becker knows that oil should always be level with the opening when the propeller is in this position. After the spinner has been reinstalled and safetied, Becker lubricates the hub with specified grease. The prop is turned so the relief fitting is on top. Then the pressure gun is applied until grease appears at the relief fitting. Becker is careful not to over-lubricate. Next, he moves to the relay located near the firewall. He checks the conduits and plugs for looseness. Loose electrical connections cause arcing and disintegration of plug contacts and insulation. Becker checks these leads in back of the relay for looseness and breakdown of insulation. In order to make a full inspection, he partially removes the relay from its box. He sees that these contacts mate properly and that there is sufficient contact point pressure. The contacts are cleaned with a lint-free cloth. They are not dressed or polished. If badly worn or burned, they will be replaced. He uses a clean feeler gauge to make sure there's the correct clearance between the movable and fixed contacts with the armature in neutral position. Another clearance in the relay that is checked is the one between the armature T-head and the upper transverse arm. The clearances on both sides must be correct. Becker examines the leads to the resistor for security and the resistor for cracks in the porcelain casing. He also makes sure that the armature floats freely on the pivot pin. After checking the T-head electrical connections and all the rest of the electric leads, Becker returns the relay to its box. He's pretty sure it's going to operate properly, but he will check the operation the first time the engine is run up. Flight's now ready to check the propeller control linkage, so he moves the stand to the inboard side of the engine. The bell cranks are checked for side play and the control rods for proper adjustment and safetying. White relays to Moore in the cockpit to move the controls so we can check for lost motion, full and free movement, and creeping. The increase and decrease RPM position of the propeller pitch control unit is inspected at the governor. The adjusting screw is checked for correct position and safety. Now Becca goes to check the left propeller. While engine specialists Sullivan and White start the inspection of the right engine. Sullivan starts by checking the condition and security of all fuel hose connections and oil lines. He also sees that they do not rub or chafe. Uh-oh, here's a loose idle clamp that needs tightening. All clamps and bondings are checked with the same thoroughness. He inspects the engine mount for proper protective coating and for cracks in the welded angles, as well as the mounting bolts for tightness, the engine cowl ring for condition, and the supports and brackets for cracks. The deflectors, blast tubes, and baffles are examined for cracks and loose rivets. He also makes sure they do not rub against the fins. Sullivan thinks he's found a baffle that's cracked at the ear, so he takes off the deflector to check the baffle thoroughly. After close examination, he decides the baffle is in good condition, so he replaces the deflector. Cylinder head rocker box covers are checked for cracks and oil leakage. This leaking one needs tightening. Sullivan knows from experience that he must not exert more pressure than is specified by the tech order, or he will strip the stud. Cylinder fins are checked for cracks, dents, or any other damage. As this dented fin is not cracked, it will be returned to its original position. He inspects the cylinder hold-down nuts and the pal nuts for security. That's right. Those down and back that are hard to see are just as important as those in plain sight. Sullivan inspects the intake pipes for leakage and looseness. Leakage can be detected by evidence of blue aniline dye around the packing nut. Exhaust stacks are checked for cracks, blown gaskets, and loose bolts. Intake pipe packing nut seals need replacing if excess tightening has made them defective. The chevron clamps should be snug, but not too tight. Otherwise, due to heat expansion, they will crack the exhaust manifold. Now he's inspecting the spring for tension. By tapping the exhaust stacks and the collector ring lightly, he loosens the scale. Clamps and bolts get a thorough going over, as the brackets must be secure and free from cracks. After tapping, some of the scale can be cleaned from the exhaust with a wire brush. In the meanwhile, Sullivan sees that the push rod cover tubes are tight, and the packing nuts are safetied and not leaking. The packing nuts should be snug. The lagging is checked for security and safety. Next, he checks the oil cooler flap assembly for side play due to bushing wear, the actuating rod and bracket for safetying and security. As Moore in the cockpit moves the control system, Sullivan checks the operation of the assembly to make sure it works easily and does not bind. The same thorough inspection is made on the cowl flaps, the cowl flap brackets, and the push-pull rods and bushings. The movable cowl flaps and the oil cooler flap hinges are lubricated at this inspection period. In checking over maintenance and inspection form 41B, Crew Chief Moore found that Sullivan had not initialed several inspection columns on the 50-hour instruction form. So he calls them over to initial what's been done, so it can be entered in Form 41B. Moore doesn't want the boys to miss even one item. With the form up to date, Moore returns to the cockpit. White examines the carburetor air scoop for security and general condition. The heat control shutters, cables, and turnbuckles are checked thoroughly. The cables are inspected for frayed strands, especially where they go over pulleys and guides. The carburetor throttle, mixture control, and propeller control cables are inspected for fouling against the carburetor heat control cable. White now teams up with Moore in the cockpit to make a thorough checkup on the entire engine control installation, including all rods, cables, linkages, brackets, and pulleys. Moore now checks to see if the controls spring back 1/8 of an inch after being placed in the full open or full closed position. White observes that the full movement is transmitted throughout the control linkage to the carburetor. The mixture control in the cockpit is checked in every position from idle cutoff to full rich against similar action of the mixture control lever at the carburetor. Sullivan has now climbed into the cockpit to check all engine control rods and cables in the pilot's pedestal. He first has to remove the 3 sections of cover plate to get inside the pedestal. He checks the self-locking nut on the through bolt supporting the bell cranks for tightness. Then he cleans the control linkages. Checks the bell cranks for side play and looseness of bolts because of the strain that's being borne by the rods and bell cranks. And he sees that all nuts are safety. He checks the control rods for creeping, bending, and fouling against one another. These controls must operate smoothly and be correctly adjusted. Sullivan now moves into the navigator's compartment and checks the control cables. A cable with more than 6 strands broken within 1 inch distance must be replaced. He lubricates the control cables according to technical order specifications. Then he turns each pulley 1/4 of a turn to spread the surface of wear. He also makes sure they do not bind. Brackets holding the pulleys are checked at these points for cracks and security of mounting. This finishes column 20, engine controls, so proper entry is made in Form 41B. Well, White appears to be finished with his engine inspection. Or is he? White anticipates trouble whenever he's around the airplane, for he knows that when aircraft are inspected carefully, structural failures can usually be detected. Crew Chief Moore and his men are aware that a large percentage of crashes can be traced to faulty inspections and poor maintenance, and that proper inspection, pulled at the proper inspection period, will eliminate most common troubles. With both engines and propellers thoroughly inspected, Crew Chief Moore calls the boys together to check up on the work they have done so we can enter all columns completed on the Maintenance and Inspection Form 41B. He wants to make certain that not one single item has been overlooked and that Maisie is in perfect shape to let the Axis boys have it.